So with that said, I'm going to go ahead and go into a 10-minute introduction of Kubeflow, which is a bit of a Herculean feat, but we're going to see if we can't make it happen. And we're going to basically cover three things, right? Why Kubeflow, the basic architecture of Kubeflow, and then double-clicking within that architecture to investigate some of the main components and the role that they serve. And then we'll kick it off right into Peter's talk. Okay, so the first question to ask is why Kubeflow, but there's even a more rudimentary question to ask than why Kubeflow, and that's going to be, what does machine learning and data science have to do with Kubernetes at all, right? So we're kind of leveling up here first. Before talking about Kubeflow, what the hell does machine learning and data science have anything to do with Kubernetes? Well, there's three main reasons why, if you're doing machine learning or data science, you should be thinking about doing putting those workloads on Kubernetes. The first one's going to be portability, right? This isn't anything new or earth-shattering, right? You want to write once, reproduce, and run everywhere, right? The idea of, hey, it worked on my laptop. I don't understand why it doesn't work on these Megatron clusters running in the cloud, right? Well, they're two completely different operating environments. So the more that you can kind of level the playing field on configurations and all that good stuff, containers are a way to make that happen, right? And that's like a classic workflow, right? Data scientists work on their laptops, they hand it off to the DevOps or the MLOps people, and now they have to run it on GPUs on big clusters running in the cloud. A lot can get lost in translation in that way, right? So portability is a key reason why you may want to consider combining Kubernetes with your machine learning workloads. The other one's going to be microservices, right? Microservices was one of the key drivers for Kubernetes coming onto the scene or getting popular. It's just the new way that everyone is developing applications, whether you're decomposing existing applications or from scratch building new services, APIs, or apps. Microservices is the way to go. And because Kubeflow, as we'll see, is not just a single monolithic binary that you double click, you install, and boom, there it is. It's actually a bunch of different services or components that are stitched together to create a platform or an MLOps platform. Because these are all different services, a microservices-based architecture that runs on top of Kubernetes is a no-brainer, right? And then the last one is going to be scaling. So here it's not always about, hey, how quickly can I get access to the resources that I need to run my machine learning workload? It can often be just as important, how quickly can I spin it down and release those resources? Why? Well, it's a bit unique to machine learning because, as you know, machine learning workloads love GPUs. GPUs are expensive, and even at the most deep-pocketed enterprises, every data scientist doesn't have access to dedicated resources. They normally have to share it with others. So Kubernetes or containers are going to provide an excellent way to scale up the infrastructure that you need to do the work that you need to do, and then also relinquish it and let it go and let others use it, kind of like a modern timeshare system, so to speak. But those are three reasons why Kubernetes has anything to do with machine learning and data science: portability, microservices, as well as the ability to scale up and down. Now, let's kind of look at it from the business aspect, which is there's two big trends that are happening in IT that are relevant to this particular conversation. The first one, everybody's going cloud native. I think that's a no-brainer here. Everybody knows that. Kubernetes is everywhere. Everybody's thinking about Kubernetes. Now, the other thing is that everybody, and here I'm talking, say, Fortune 1000 companies, a lot of them are either thinking about or are well on their way with doing machine learning and data science, specifically in the enterprise, right? And this one's kind of weird because in the last 20, 25 years, who were the last companies to adopt open source, the web, mobile, right? Even Kubernetes, all of this stuff, it was always the enterprise, right? What Gartner calls these laggards, right? They're always the last ones to adopt this technology, right? Open source, there's no vendor. It's insecure. I'm not going to use that stuff. The web, who wants to do their banking on the web? Mobile, everyone wants to come into a store. Who wants to buy things on their mobile phones, right? So the enterprise is always lagging behind all these big trends. But here I think it's completely different, right? Where machine learning and data science, some of the most innovative stuff is happening at what most people consider boring companies, right? Whether they be financial services, banking, insurance, healthcare, mining, oil and gas exploration, machine learning and data science is there, lock, stock, and barrel. And I think the reason for that is going to be that you got to have access to the data. Enterprise has access to large amounts of data. Second is that it's expensive to hire, retain, and train data scientists in machine learning. So you got to have budget for that. And the third one is going to be that the infrastructure that you need to do machine learning at scale is typically pretty expensive. So you got to have IT budget as well. So I think all these kind of reasons kind of come together to show like, hey, this is kind of the first time in one of these big trends where the vanguard is actually these old school companies that we don't always think of as being on the cutting edge. That's an interesting kind of thing that I haven't seen in 20, 25 years. However, despite all of this awesomeness, most machine learning models never make it to production. So depending on whose data you look at, Gartner, Forrester, et cetera, maybe it's 40%, maybe it's 60%, maybe it's as high as 70%, just no one won't admit it, is machine learning models tend to not make it to production or fail to deliver the business value, right, that was promised. And there's a couple of reasons for this. The first one's going to be the skills gap, right? Many people that are coming into this field, it's just a new field, right? There just isn't super experienced people that have 10 years of experience doing this sort of stuff, right? So there's a definite skills gap. The second one is going to be the software. A lot of the software that's being cobbled together is still like sub 1.0 or it's 1.0 or 2.0. So a lot of the software itself is still being worked out. The next one is going to be an MLOps methodology. Now, if we wanted to hire an agile coach or a DevOps coach, we don't have to look very far. There's thousands of them that can help our company start doing DevOps. MLOps, not so much, right? There's a lot of ideas on how it should be done, but every single company that you go to, they're kind of figuring it out as they go along. So not having a prescribed way of how to do machine learning, going from essentially development or laptop to production at scale, say in the cloud, there's no clear-cut way about how to do it. At least that part is still being figured out. And of course, if you work at a big company, you know how hard it is to collaborate across teams, especially if you've got data scientists that have to work with DBAs and data engineers that have to in turn work with security people, which in turn have to work with DevOps or ops people and SREs. And, you know, God forbid in the end, our models are unethical and then the legal people get involved. So it can be a large swath of the company that can get involved in this sort of a project, and collaboration, I don't have to tell you, can be challenging in that respect. But there's Kubeflow. And that's the awesomeness of Kubeflow, is that when machine learning and Kubernetes converge, Kubeflow is kind of the logical output. So the quick history lesson is going to be, Kubeflow was launched back in 2017 by Google. It was essentially a project that was spun out. They used it to run their TensorFlow projects. And since then, it's kind of been the most robust machine learning platform that is cloud native by design, not as an afterthought. Right, so we may think of other machine learning platforms. Those often have to run on bare metal or proprietary flavored versions of their infrastructure. But Kubeflow was designed from the outset to run on Kubernetes. So it's never an afterthought. It's always a first order consideration. And with the idea being here that it's a platform that can be used not just by data scientists or not just by the ops people, but it should have tooling that allows everybody in whatever role that they have be able to use Kubeflow to get their work done. So it aims to be a complete toolkit for managing the data, the training, the tuning, the serving, as well as the monitoring. So let's dive real quick into the architecture and components. Now, I know there's a lot to consume here in this graphic. All we really want to walk away with is that Kubeflow basically has a set of core components or pieces of functionality. These are going to be the stuff in the blue cells. And then you've got this additional tooling, right, that is integrated into Kubeflow so that you can interact with the different components a little bit more productively. And all of this is going to run on top of Kubernetes. And of course, Kubernetes is going to run wherever you want to run your Kubernetes, which is going to be your public clouds, on-premise, or even locally, right? The idea is that as long as we base everything on containers, as long as those containers can run wherever we want them to run, we technically should be able to have that degree of portability. The other thing, the quick takeaway here is that you can see that, again, Kubeflow is not a monolithic piece of software, an executable, or a binary. It's a ton of different components that are stitched together in order for them to work. And this is kind of where SDO will come into play here a little bit later. So let's do a quick component overview. We're going to cover the central dashboard, notebook servers, pipelines, KF serving, CADAB, as well as the training operators. Central dashboard. Okay, so this is the thing that most folks primarily are going to interact with unless they're using the SDKs. Your central dashboard is going to be your browser-based UI where you can interact with all the magic. So this is going to be where you interact with pipelines and notebooks, Katib, and your artifact store, and if you're using multi-user mode, as well as manage your contributors. So there is a UI that's built into Kubeflow. Now, Jupyter Notebooks, that's where data scientists are probably going to spend a lot of their time. So for those of you not familiar with Jupyter Notebooks are going to be useful in interactive data science and scientific computing across a variety of different programming languages, although Python seems to be the flavor of choice for now. It's an open source web-based environment for creating Jupyter Notebook documents, and these documents are going to follow a version schema contained an ordered list of input and output cells, and they can contain things like code and text and math and plots and rich media, as you kind of see on the right-hand side. One thing to look out for is the term notebook can refer to the web application, the web server, or the document format. It really all depends on the context of what documentation or copy that you're reading. So just a thing to look out for. Now, how do Jupyter Notebooks kind of manifest themselves inside of Kubeflow? So Kubeflow has a notebooks web app that enables you to spin up notebook servers. And these servers can contain multiple notebooks. However, the typical thing that you see is going to be a one-to-one mapping, but it doesn't mean you can't have a many-to-one mapping as well. So Jupyter Notebooks, one of the pluses is they're going to integrate with a lot of the enterprise authentication and access mechanisms that you may already have in place. So that's an upside. And you can create pods and servers directly on the Kubeflow cluster using the images that are typically going to be provided by your admin. So this is going to give you a degree of reproducibility in regards to your environments or your images. And then the last one is that you can also submit single node or distributed trading jobs without having to get all that mumbo jumbo configured on your laptop. Up next, pipelines. So Kubeflow Pipelines is a platform for building, deploying portable, scalable machine learning workflows. It manifests itself as a UI. You can see that here in the right-hand side. And it also includes an engine for scheduling multi-step ML workflows. So this is typically, I think, going to be Argo workflows. But you do also have the option of interfacing with two SDKs. The first one is going to be the stable SDK for defining and manipulating pipelines and components. But there is also a V2 SDK that's in beta that's going to add support for tracking pipeline runs and artifacts using ML metadata or MLMD. The next piece is going to be KF serving, which is now known as KServe. So depending on what documentation or blog post you read, those terms may be colliding with each other. But just understand KServing is now KServe. So model serving is just simply the act of making a machine learning model available for others to use. And by others, we mean other data scientists, services, applications, APIs, web apps, whatever it is, right? So KF serving provides a Kubernetes CRD for serving machine learning models on a variety of frameworks. It's agnostic. So out of the box, TensorFlow, XGBoost, PyTorch, etc. But because it's all open source, there's really nothing that says that you can't tweak it so that it can support some framework that isn't listed here. The idea here with KF serving is that we want to encapsulate a lot of the complexities that are going to come with serving models, auto-scaling, networking, health checking, and server configuration. The next component to be thinking about is going to be Katib. Now, Katib is going to provide the automated machine learning, or AutoML as it's known, inside of Kubeflow. So AutoML is basically the idea of how do we make things like hyperparameter tuning, early stopping, neural architecture search, and a bunch of other sophisticated machine learning techniques. How do we make those accessible to more mere mortals, right? And one way to do that is through AutoML. So Katib is going to be the gateway for folks to be able to get access to that rich machine learning functionality. Like KF serving, Katib is agnostic to your frameworks, but there's a few that are supported right out of the box. Training operators. So in Kubeflow, you train machine learning models with operators. With the 1.4 release, all but the MPI operator have been consolidated into a unified operator. And there's currently 5 operators that are supported out of the box: TensorFlow, PyTorch, MPI, MXNet, and XGBoost. However, again, this is open source, so nothing says that you can't crack open the can and try to get another operator in motion. Now, I know that that was the express version of an introduction to Kubeflow, but if you want the less hyperactive, more in-depth version of getting introduced to Kubeflow, we do have a couple of free courses that we have set up, and let me grab the link for that, and I'll go ahead and post that here in the chat. So if you want to basically, if you're brand new to Kubeflow, so if you're a beginner, or maybe you know about a little bit about machine learning, a little bit about data science, a little bit about Kubernetes, and you want to step-by-step build your knowledge, then I would recommend this as a good starting point to kind of work your way through Kubeflow fundamentals, getting familiar with notebooks, understanding how pipelines work, et cetera, et cetera. If you're an intermediate to advanced user, this is probably not going to be interesting to you. I would recommend some of the stuff Alex is going to talk about later that's a little bit more hands-on, get your hands dirty with a little bit more practical examples. But if you're completely brand new to Kubeflow, this is going to be a good starting point for you. So this is the last slide where I'm going to yap, and this is going to cue up Peter's talk around SDO. You might be asking yourself, what does SDO have to do with Kubeflow? Well, let's back up a little bit, right? So SDO, for those of you who probably know, it's a popular open source service mesh for Kubernetes, right? And remember, Kubeflow runs on top of Kubernetes, right? We're getting there. So a service mesh, right, for folks that are new, is a dedicated piece of infrastructure that's built right into the app. And when we talk about an app, we typically are going to be talking about a bunch of services that come together to kind of deliver this thing that we call an app. So what SDO does is that it controls how these different services share data amongst themselves. And remember, Kubeflow at the end of the day is just a bunch of services, right, that are stitched together to deliver a machine learning platform. So what SDO does is that it meshes these services together. Clever, huh? Now, Kubeflow can run without SDO, but it is the recommended solution by default for managing authentication and access control between the different components and some external services. So that's where the connection happens between SDO and Kubeflow. And the last piece here before I hand it over to Peter is that if you hang out in the forums, if you hang out on the mailing list, or if you hang out in community Slack or on GitHub even, inevitably once a week, there's always a handful of questions about, I don't understand how SDO does this or how it works or whatever. So that's why I thought it would be great to have Peter come in and talk about SDO so we can learn about how SDO works in general, and then we'll have better context when we interact with it inside of Kubeflow.